Hi guys, welcome to our very first release of Math Bites, where we present quick and fun math problems for you. Today, our problem is as follows. Consider the following shape, which is a 13 by 13 grid, but with the four corners and center block removed. The question is simple. Can we fill this shape up using only T-pieces, as shown on the right? I'll give you a while to think about it. Since our shape has 164 blocks, which is a multiple of 4, we might say that it's obviously possible. However, if we try actually filling in the board, we'll realize that no matter how we seem to place the T-pieces, there's always going to be a hole left somewhere. Even though our intuition tells us that it's impossible to tile the entire shape, we still need to find a proof for why this is true. To prove that it really is impossible, we first color our shape in a checkerboard pattern with dark and light squares alternating. Notice that out of the 164 total squares, 80 of them are light colored and 84 are dark colored. If you don't believe me, you can count them for yourself. Next, we'll consider how many squares of each type a T-piece could cover. What we'll realize is that no matter where the T-piece is placed, it always covers 3 of one color and 1 of the other color. To see why this observation is useful, we'll jump into algebra territory. Let's let D be the number of pieces that cover mostly dark squares, and L be the number of pieces that cover mostly light squares. Recall from before that our shape had 84 dark squares and 80 light squares. We'll now set up some equations. Notice that each mostly light piece contributes 3 light squares, while each mostly dark piece contributes 1 light square. Because any tiling of the shape has to cover every individual square, that means our T-pieces have to cover all 80 light squares. Therefore, we can set the total number of light squares, 80, equal to 3 times the number of mostly light pieces, plus 1 times the number of mostly dark pieces, or in other words, 80 equals 3L plus D. Similarly, each mostly dark piece contributes 3 dark squares, while each mostly light piece contributes 1 dark square. Therefore, we can set the total number of dark squares, 84, equal to 3D plus L. Since we have 2 equations and 2 variables, we are able to solve for the exact values of D and L. Doing that real quick, we get D equals 21.5 and L equals 19.5. But wait a second. Remember that we defined D and L as the number of T-pieces that cover mostly dark squares and mostly light squares respectively. But this requires that D and L must be whole numbers, which contradicts what we found. So, our final verdict? Due to this contradiction, it's actually not possible to tile our original shape with T-pieces, no matter how hard we try. Thank you for watching.